So now let's check out a subtraction problem. And I want to show not only fractions greater than 1, but also another set of denominators so we can practice this idea of how the models, especially the set model, but the other ones are also the same way, as very true, can do the same thing. But the set model is especially helpful for seeing this idea of common denominators. So again, if we have a 3 thirds and eighths, you tell me, go ahead, how do I create this whole to show 3 thirds and eighths? How many dots should I put in my set? And again, use pictures of kittens, of butterflies, of cars, of whatever, if you would like to make your set that way and don't just want to use the dots. Oh, you said do 1 row of 8. And how many rows of 8 should I do? 3 rows of 8. Why should I do 3 rows of 8? Because I want my whole to show both thirds, right? Both thirds. We can see that here, right? 1, 2, 3. 3 rows, both thirds, and, yep, you're right, eighths. 1, 2, 3, 4, 5, 6, 7, 8. So you can create this 3 by 8 array, and that is how we want to define our whole. So just as before, I'll just copy and paste, right? This equals 1 here. But now what is, and then a great kind of step to take to orient yourself is to define these unit fractions for yourself. So what is 1/3, and then what would be 1/8? All right, what do you think? 1/3 is, yep, just like before. And so if this one's too similar to the one before, then I'll just move this over, right? Well, choose a different number. It's going to be the same, right? One of the unit fractions is always going to be a row. One of the unit fractions is always going to be a column, if that's how you make your whole, right? If you define your whole by the two denominators, right? One is the rows, right? A 3 by 8 array. If you define your whole in a different way, like think about fourths and sixths. If you do a 4 by 6 array, it'll be the same. One will be rows, one will be columns. If you think about fourths and sixths and think about, ooh, a common denominator is 12, well then, one whole row or one whole column is not going to be 1/4 and the other one be 1/6, right? Because you only have 12 counters. If you had this 4 by 6 array, then you would have that relationship. So it's, again, how you define the whole is how you get your fractions. And now here's 1/3, here's 1/8. We want 4 thirds. So what I'm going to do is I'm going to group these, right? We want to show 4 of these. 1, 2, 3, 4. And maybe I can even change some colors or move some things around so that way I'm running out of space and it's all going to. And so if you think about, right, one of the things we do want to talk about are the advantages and disadvantages of each of the models. Why this was really helpful, right? This set model in defining this whole, right? Just choosing the array. However, you see, like right now, it's getting a little crowded. And so this is one of the disadvantages, right? Because everything is its own discrete piece, it's really easy to kind of get them mixed up. And so that's important to note, right? To understand both the advantages and disadvantages of each of these models. So here's 4 thirds. And now we want to take away 7/8. So, or think about subtraction as find the difference between, right? Where we're like comparing. So we can create 7/8. Let me see if I can just do that real quick. Oh, look at that, right? We want 7 out of those 8 columns. And maybe what I'll do is I'll change these colors. And now, whoa, right? We're going to compare. So what is left over? 4/3 minus 7/8, or pretend that all these purples I'm taking away, and I can see 1, 2, 3, 4. I'm gonna put an equal sign. And maybe, again, maybe I should, I'm going to do this, but now I'm going to arrange them so that way they look like, right, we had a 3 by 8. So I'm going to put them in 3 rows. Ooh, look it, we don't have, so we don't have a whole 1, 2, 3, 4, 5, 6, 7, right? We don't have equal number of rows or equal number of columns in this now. So we don't have, our answer is not in sevenths or eighths, but it's in, or sorry, sevenths, thirds or eighths, but it's in this common denominator, right? Here I can see I have 11. I'm just gonna, oops, use this so I can label it, right? This is gonna be then 11 24ths, right? Is this difference or distance between these numbers. And it's not really distance, sorry, because it's a set model. Or you can think about it as take away, right? If we took away these 7/8, we would think about what was left over. I could have literally deleted them, which may have been helpful. So think about, what makes the most sense to you. And if you look now at this static representation, this is why it's tough. And I want you to, and that's why I really want you to encourage you to do it in video so you can see this action of take away. Or if I had enough room, and maybe I'll try and rearrange it here so that way the final representation is helpful, is really showing these two fractions separately, right? It's not gonna work right now. Okay. So again, now take a turn. Maybe try 3/5 minus 1/4, or try, we talked about sixth and fourth. So 3/4 minus 1/6, or 5/6, 5/6 minus 3/4, right? What are the differences? Or and then add them together. Adding and subtracting fractions are about the same procedures. As you can see, it's just in the end, when we add, we talk about like just put together, combining, right? That is what add means. When we subtract, you can talk about take away, like we can take away all of these purple ones and we're just left with these blue on the outside. Or again, the difference between, right? We're comparing. So these meanings of subtraction translate to even when we're subtracting fractions.